So yesterday we talked about the theorems that establish a relationship between the special angles. So right in section 1 we talked about definitions of like parallel, skew, perpendicular, that kind of stuff, right? Then in 3.2 we talked about in 3.1 we talked about the definitions of alternate interior, alternate exterior, corresponding, and consecutive interior. Then 3.2 you learned that if the lines were parallel, which 3 types of pairs are congruent?
Oh, you asked.
Yep.
So your all interior angles.
Okay. So the congruent ones would be alternate interior,
Alternate exterior.
alternate exterior,
And corresponding.
and corresponding. So that leaves what for the consecutive R?
When the interior
Good.
angles are.
So those are all the theorems and postulates we learned yesterday. They are all theorems with the exception of which one? Corresponding is the postulate, right? Okay. So this one says what theorem justifies each statement. You're looking at the first one, 3 and 6. What's the relationship between 3 and 6? Good. Alternate interior angles theorem. You have to have theorem on there because otherwise you're saying it's a definition. The definition doesn't make them congruent. The definition just establishes that relationship.
Is it alternate or alternative?
Alternate. Yeah, alternate. Alternate interior angles theorem. Yep. Okay, and then 4 and 6 are here and here. If these are supplementary, what is that? Consecutive interior.
Did you also say same side?
Yeah, same side's also okay.
Can you like
Did you
just
say
put
same side angles
consecutive?
too?
I forgot about
Say again?
Same side angles. Yeah.
Yep. Okay, and then 3 says if the measure of angle 2 is 115, find the measure of angle 7.
X.
They are alternate exterior, which makes angle 7 what?
115 degrees. So it's congruent.
Good. 115, and that's alternate exterior angles theorem.
Could it also be linear? Oh, not linear. Vertical angles.
If you went 2 to 6, then you could go, yeah. So there's lots of different ways. You can go 2 to 6 because of the corresponding angles postulate, right? And then 6 and 7 vertical angles. Or you can go 2 to 3 vertical angles, 3 to 7 corresponding. You can do that. So there's lots of different. What one step would be alternate exterior?
Before we go over the next one, is it like this? This would be like a corresponding angle, so this would be 6x.
Only if these are parallel does that work. So the only parallel lines you have are these.
So they're the measure.
All right, then you had this diagram on the right-hand side, which, again, we want to pay attention to the little triangles that are marked, right? Those two mean that those lines are parallel. My advice is if it's hard to see it, extend those lines out because you've got those two parallel lines and you've got this transversal, and then you also have this transversal. Those are two different transversals, okay? So when you're establishing a relationship between what's there, okay, where 6x is, God bless you, where 6x is, the only other angles you have on the yellow transversal are these, and together those two make one angle, right? What's the relationship between this whole angle and 6x? Not equal. Equal and congruent are the same thing. Not that.
They're supplementary.
Why are they supplementary?
Because they're on the same side.
Because they're same side interior. Does everybody see that?
Yeah.
So this side and this side on that yellow with these being your parallel lines, those are same side interior or consecutive interior, which means they're supplementary. So 2x plus 10 plus 30 plus 6x equals 180. 8x plus 40 equals 180. 8x equals 140, and x equals, divide that by 8. Should I do that right? Yeah. 7 and then 6. Nope. 1/2.
I told you it wasn't that. Can we do decimal?
Sure. 17.5. Same thing. Yep. Okay. That's for x, right? That was x. Then it said find y. So now I know. Let me erase all this stuff off. You can do this a couple different ways because, again, this is parallel. This could be one transversal. So one relationship I could establish is between y plus 10 and 2x plus 10. What would that be? Alternate interior, which means they'd be equal. So I can take this 17 and plug it in here. 2 times 17.5 plus 10, or 35 plus 10 is 45, and that equals y plus 10, which means y is 35. That's one thing you could do. Okay? The other thing is you actually have a triangle here. So we haven't talked about it this year, but that is something that you bring in here, prior knowledge on triangles. What's true about all the angles in a triangle? They add up to 180. So I could also plug the 17.5 into the 6x here, and then add the 30, what I get from the 6x, and the y plus 10 together to 180 to find that.
Wait, you scared.
Huh?
So you got 45 by plugging x in,
So I plug the x into this one,
and then you made it equal.
and that's 45.
Okay.
And then I said that had to equal this whole angle, so 10 plus x. Or, y plus 10 is 45.
What does a triangle have to do?
You could also have done it that way, because if this is 30, this you can find by doing 6 times 17.5. Add that to the y plus 10 and set it equal to 180. You could have solved it that way too. Yeah.
Are there any ways you can make it look more like a normal without like the shapes in it? Because like the shapes kind of confuse.
You're going to see them. You got to get used to it. So my advice is, Connor just asked, like, here he said that those shapes kind of confuse you. The more complex those images get, the harder it's going to be. And that's when I would kind of just like section it off. So like cover it with your hand, draw them out, like do what you have to do, especially on your quiz. You guys, I'm going to stop. As you're working with it, you might be able to just focus on this one and this one for a little bit. So you can even use colored pencils, color those in differently. Look at them that way and then say, okay, maybe there's a transversal coming this way. Now I want to focus on these and that transversal. So either darken it, do a different color, something that helps you establish that there's different stuff going on there.
The other ways you could do, you just plug the 17.5 into 6, and then you add that to the 30.
And the y plus 10, and set them all equal to 180 if you're using the triangle. Yep. Okay, number 5 says the figure shows a plant trellis. If the measure of angle 1, which is here, is 82 degrees, find the measure of angle 2. What's the answer?
98 degrees.
Why?
Because, see, what I did was 2 would be an all interior, 2, I just drew a 3, and then I just said that would equal 100. So like,
But if you did that, your 3 would be here, right?
No, the other side, by the 1.
Here.
No, above it. Like, it's going to be
Here.
No, it will be a consecutive 2.
So consecutive interior would be here,
Are these corresponding? Corresponding.
right? So you got it in the wrong spot because that doesn't work. Good.
Corresponding.
These would be 180, right? But not 2 with 1. 2 and 1 are actually corresponding, which means what?
Congruent.
They're equal.
I looked at it wrong.
Yeah, just be careful. So that's the corresponding angles. Postulate. Corresponding
As long
postulate.
as you remember all the theorems that you just said at the beginning, you can find.
Yeah. Like you're gonna, obviously there's 2 ways because we're gonna flip-flop this in a minute and start looking at the other way. But the first way is that if you are given that there are parallel lines, then you know all those relationships about those angles. You know the alternate interior are congruent, alternate exterior congruent, corresponding are congruent, and consecutive interior are supplementary, right? You know those 4 things. And then today we're actually gonna take and we're gonna flip that and say, if we know that about these lines, then I know the lines are parallel. So you're flipping. We're flipping the whole thing today, okay? Basically taking every single one of those and making it its converse is what's happening. But it's just more practice on the same thing. All right, this is 30. It says to find x and y, right? So there's actually 2 sets of parallel lines going on here, but they are parallel to each other. So you can establish the relationships between the individual pairs, or you could have even gone top to bottom. It doesn't matter because they're all parallel. So I've got one transversal that's running here, right, which would make 60 and 3x have a relationship. Corresponding, which means 3x equals 60, x equals 20. Then you've got a transversal over here. Yep. So this one and this one are same side interior. 5y minus 5 plus 135 is 180. because they're same side interior. They're two separate transversals, separated off.
No, so that's how you find this stuff. I was just confused with like what to do.
All right, 35 said find the value of x and y. Look at this now that we just talked about what we talked about. Here's the difference. There's two variables built within these equations, right? So if this is parallel and this is my transversal, what's the relationship between 60 and 2x minus y?
Oh, same side.
Same side interior, add up to 180. So 60 plus 2x minus y equals 180. How about if these are my parallel lines and this is my transversal?
Same side.
Also same side interior. 2x plus y plus 40 equals 180. So now, if you think about like all the properties that we know, if they both equal 180, what can I do with that?
Oh.
You guys are so smart. So them equal to each other, substitute it in. So 60 plus 2x minus y equals 2x plus y plus 40. Subtract the 2x. And now I'm down to one variable. So without that, you'd have to do a systems of equation, but they made it so you could do it. Subtract the 40. Divide by 2. There's your y. And then what do you got to do with it? Plug it back in. You can plug it back into any of them, but let's say I grab the first one. All right, so again, corresponding angles, converse postulate. Important is obviously we know corresponding angles postulate from yesterday, right? Corresponding was the one that was a postulate. But now it has the word converse in it. So you can write corresponding angles postulate converse or corresponding angles converse I don't care the order there, as long as it has both words, okay? But basically what it says is if I knew that these two angles were congruent, then I can prove that J is parallel to K, and the reason is this, okay? Corresponding angles converse postulate. Then comes alternate interior angles converse and alternate exterior angles converse, which say exactly the same thing minus one word. If two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. And the alternate exterior says if two lines are cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. All right, consecutive interior angles, converse, last pair of special angles. Okay, this time consecutive interior, remember, was supplementary. So if the lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So this one, just like the reverse of it, it has to be supplementary while the other ones are congruent. All right, then the transitive property of parallel lines actually works, okay? It says if two lines are parallel to the same line, then they are parallel to each other. So if I had a diagram and it said M is parallel to N, so if M is parallel to N and N is parallel to P, then my transitive property would say what?
M is parallel to P.
Exactly. Make sense? Yeah? Okay. All right, so this is all of them. These are the 5 ways that you can prove that lines are parallel. I got you. Okay? The first way, I want you to hurt yourself. The first way is that you can show that one pair of corresponding angles are congruent. The second way is that you can show a pair of alternate interior angles are congruent. The third way, same side interior angles or consecutive interior angles are supplementary. The fourth one, wait, I'm missing one. Alternate interior, alternate exterior. There's 6. I didn't even notice that. 6, they're not necessarily in any order, show alternate exterior angles are congruent. Okay, so we've got corresponding congruent, alternate interior congruent, same side interior, consecutive interior supplementary, alternate exterior congruent, and then these 2 that have to deal with perpendicular and parallel. In a plane, show that 2 lines are perpendicular to the same line, or show that both lines are parallel to the same line. So there are 6 ways to prove lines are parallel.
Could you do an example for number
4, yeah. So if I had, almost like what we did in the homework, minus that we didn't know that this is what it was. God bless you. It's frozen. Okay, so because M is perpendicular to P and N is perpendicular to P, M and N are parallel. So this would be like given, it won't be this easy, but given M is perpendicular to P and N is perpendicular to P, I can prove M is parallel to N because if 2 lines are perpendicular to the same line,
because the line keeps on going and it's
okay, so it's another way to prove they're parallel. If 2 lines are perpendicular to the same line or 2 lines are parallel to the same line. All right, so this one says which segments are parallel. Notice you've got a bunch of segments there. You've got AB that's on the bottom. Obviously, that's not going to be parallel to anything. So then the question is, I've got BF. That looks like it could be parallel to AD.
No.
But if this is my transversal, what would have to be true about this angle and this angle?
It would be the same.
They'd have to be the same because those are corresponding. So those are not parallel.
Could you just do it based on how you see it?
Nope. No, because it doesn't necessarily mean it's drawn to scale. So then this is still a transversal, but now let's test out this one and this one. So if those 2 are parallel, then this and this would be corresponding. Does 24 plus 36 equal 22 plus 38? Yep. So those are parallel.
Okay, so what would be the reason?
Corresponding angles, postulate, converse.
What about AD and
No, because it's 36 and 38. So if those were the same, then yes. But they're not.
But if they're corresponding, wouldn't they be? If they're corresponding, wouldn't they be equal to each other?
Only if the lines are parallel. You don't know the lines are parallel yet, so we're working the opposite direction.
Oh, okay.
Yeah.
This does say corresponding.
Corresponding angles, postulate, Converse.
So if it was just asking about A, D, and B if they're parallel or not.
Nope.
Just both angles combined.
They right.
Wait, this is a corresponding.
What's it say?
Oh yeah. It'd be
What's the value of x that makes AB parallel to CD? So if AB was parallel to CD, what would be true about the relationships of these angles? What are they? What are those relationships? What's that relationship called? Corresponding. So if the lines were parallel, those would be corresponding. And if the lines are parallel, what's true about corresponding angles?
They equal each other.
They'd equal to each other. So this 90 should equal x plus 40. So in order for these to be parallel, x has to be 50.
They were just basically asking for the value of x to make it
To make it parallel.
okay.
Right. Because without it being parallel, there is no relationship there. You don't know that 90 equals x plus 40. Unless you're saying what value of x would make it. And that's what you're trying to find. Only if x was 50, those would be parallel.
So regardless of the shape, they would have to have the parallel marking to know if it's parallel.
To know, yes, unless you're proving it like with using one of these. Yeah. Okay, so find the value of x and y that make J parallel to K and L parallel to T. So I've got two sets of lines working here. J to K is here, right? And there's two transversals. If I look at this transversal, what relationships are established, Jack? If those are parallel, what's the relationship along the gray transversal? What's the relationship between 60? They're corresponding. So if they're parallel, what should be true about corresponding angles? So 3x would have to equal 60 and x would have to equal 20 in order to make J parallel to K.
Oh, and then same side.
And then the other one is L to T.
Could you do alternate exterior in this one?
Nope, because this is the transversal, right? If it's L to T, I want those to be parallel. That's one transversal. There's only one angle on that, right? So then this is the other transversal. This is where I have two angles that I can establish the relationship.
That's what I meant.
Oh, alternate interior. Yeah. So alternate interior would have to be what?
They equal each other.
Equal. So 60 would have to equal 2y, and y would have to equal 30. So you're going to have to learn to block them out because there's going to be more than one transversal, more than one parallel lines.
So
Two.
for your answer, would you just put what x and y equal?
Yep. That's what they would have to equal in order to make those lines parallel.
Would it be alternate?
60 and 2y would be alternate interior. Yeah.
So would you have to explain like how you got it? Or
If it asks for it. So this one didn't say it.
so you would say like alternate interior and then another one would be corresponding.
Correct.
Are those theorems or the converse?
The corresponding is these would both be the converse.
Okay.
Yeah. Because if you don't know that they're parallel at the beginning, you have to prove they're parallel, that's the converse. If the information is given to you that they are parallel, that's the original ones.
So this is according to the
But
corresponding.
they said that it was parallel.
It's saying what values would make them parallel. So you don't know they're parallel yet. You're trying to figure out what would make them parallel. Yep. All right. How can you tell whether the sides of the pattern are parallel in the photo of the diamondback snake? So if you, I know I hate snakes too, but it's an example in your book. Okay. If you zoom in on that pattern and you'll see it here, alternate interior. So what would make them parallel?
Converse.
Good. Okay, so again, if the information you have is about the angles and you are proving the lines are parallel, that's all the converses. If you have the information that they're parallel, so you're improving or proving information about the angles, then this is your original postulates and theorems. So pay attention to what you're given and what you're looking for, because that's what's going to be able to figure out those two. The wording is both the same, right? It's just the converse to it.
Oh, wait, one right there. Oh, wait.